Hopefully this time as well, the recording isn't all choppy like it was in the previous videos, not counting last video. And I got some rest, so hopefully I will sound a little more cheery, or at least a little more energetic while making this video. So I'm going to try to make this video short, but today we're just going to be making game objects. So what is a game object? Well, it's gonna be a blueprint class that will basically, let's take a player, and let's say the player has a sword, like in Minecraft. Both the player and the sword are objects, right? And they inherit the properties of an object, right? They have a texture, they both have a position, they both exist within the game. So yeah, that's what we're going to be making, not playing. So first, let's just create a class, I mean a package called game, called objects. And then let's create a new Java class called game object, right? And in this game objects class, we're going to have a couple of attributes. First is going to be a private final string called name, and a private final, actually, sorry, no, not that. And then a private boolean is dead equals to false. All right. Let's create a constructor. And this constructor will take in a name, and we will later on, actually, you know what? Let's create a transform class. So I'm not sure if you guys have used Unity yet, or have you? I don't know, whatever. But in Unity, a game object always has this component called a transform. And the transform simply just specifies how big it is, where it is on the screen, so like its size and its position. So that's what we're going to make. So let's create a package called data structure. And in here, let's create a class called transform. And we're going to have two main attributes, or actually, we're just going to have two attributes. It's going to be a vector2f. Oh, shoot. Okay, yeah. So we're going to have two vector2f's. One's going to represent the position, the other one's going to represent the scale. What is a vector2f? It's a vector2 float. That's what that means. That's what the f means. A vector2i would be a vector2 integers, right? However, this object, I'm realizing, comes from a dependency, a library called JOML. Okay, so over here, let's just clear this up a little. So let's update this package, right? Just like that. If it's not underlined, it doesn't matter. And then down here, we'll do project.ext.joml version equals to 1.9.23. All right, and then let's do implementation org.joml joml 1.10.4. So that's going to be the version of JOML we are using. JOML is just a Java math library. I'm not sure what the O stands for. Java Objects Math Library? Maybe? I'm not entirely sure. But once you're done, press that Gradle button that appears on the top right corner. It should look like a reload symbol. Let's just run it to load the library for the first time. And now it should be all loaded. Now we should be able to use, all right, the vectors. So over here, we're going to have two main attributes, like I said, a public vector2f position. Okay, yeah, there we go. Let's import that. And a public vector2f scale, right? And let's actually make this private, because we will be having a method for the position stuff. All right, so vector2f, we're going to pass in through the constructor a position and a scale. And I actually do want to specify here that we pass in the screen coordinates, I believe, right? No, we're passing in the world coordinates, right? So we'll just say position in world coordinates, just like that. And okay, so if you don't know what I mean, when you are coding something on drawing something on a screen, right? The X and Y axis, usually the X goes to the right and the Y axis, starting from the bottom left, goes up. However, in a Java program, the Y axis is flipped. The X still goes from left to right, but this time it starts in the top left corner instead of the bottom left corner right here, right? And then the y-axis goes down. So normally in math, right, if you want to have an object, a square's position is, let's say, 50-50, right? That would be right here in the bottom left-hand corner. But in Java, it's on the top left. Now, I suspect the reason is because if you want to resize the window, then the whole axis is messed up. So it's easier to have the 0, 0 of a window in the top left where you can't really change where, yeah, you know what, fuck it, whatever. Yeah, it's in the top left. That's all you gotta know. This square's position, it's 50-50. In normal math, it would be down on the bottom left, right here, this square on the screen. And essentially, the world coordinates is going to be the regular, where 0, 0 is on the bottom left. And yeah, that's what I mean by screen coordinates and world coordinates. World coordinates are on the bottom left, and screen coordinates are on the top left. All right, anyways, now that my horrible explanation is done, let's do //world to screen coordinates, and we'll do this dot position equals to new vector2f, and now we're going to pass in the x, right? And then we're going to do window dot get height minus position dot y, right? This window dot get height minus position dot y, that just converts it from world to screen coordinates, and we're going to do scale dot scale equals to scale, right? So we're just initializing that the scale. Okay, and now let's do a public vector2f getter called position, and we're simply going to return a new vector2f where the x is the position dot x, and it is window dot get height, and then we are doing position dot y. So you can see we're doing that conversion again, and that's because we are converting it back into world coordinates, right? So when we create the position, we are passing in world coordinates, and then it sets the attribute of position in the transform to x and y in screen coordinates. And then if we want to get it again, right, we'll call this position method, and it's going to return it in world coordinates, in which case we have to convert it once again. So we'll return a position in world coordinates. All right, so then we'll do we can just type in equals right here, and it should, okay, what is that? Whatever. We'll just do at override, and we'll do public boolean object obj, and we'll do if the obj is equal to null, return false. I forgot to put in the name here, equals. It's just an equals function that compares this transform to another transform. We'll do if the object is an instance of transform t, then we'll return false. otherwise we're going to return t.position equals this position, and t.scale equals this scale. And why you giving me an error? What is this? Equals between objects of inconvertible types transform. Oh, what am I? Oh, t.scale equals. All right. So, okay, that should be correct. Okay, so why are we doing this? Well, when we are there's a built-in function called an equals function, and you can do it with any object. And just do equals. See, and what this function does is it checks if the object I'm specifying. So I can do like here, wait, let's see. Let's go into the window class, so I can do key listener dot equals, right? And basically what I'm saying is the key listener equal to, I don't know, the mouse listener, right? And it's going to see if the key listener is the same as the mouse listener in object form, right? If this instance of the key listener is the same as this instance of the mouse listener, right? And we can do that too with the transform method. However, in this case, we just want to say, all right, we're not comparing the object, right? Because let's say we have two players and both players are standing in the same exact position and they are the same exact width and height, right? They're in the same position. If we compare their two transforms, it's going to return false, right? Because it's going to say these two transforms are not equal, even though they have the same position and the same size. Why is that? Well, it's because these are two different transforms. One transform object belongs to one player, and the other one belongs to player 2. So it's like, okay, well, this isn't the same transform, but what we want to do instead is, instead of comparing the two objects, as long as it has the same position and the same size, then we will return yes, it is the same transform, right? Because, come on, there's no real difference between the two, right? Okay, that's why we're doing this equals method, and I am wasting valuable time. It's been 12 damn minutes. All right, so we've created the transform class. So I'm actually going to end the video here, and next video we will work on the game object. Yeah, so sorry, not that much progress today, but hopefully